Hi, my name is Julia Mertz, and I am happy to share with you a summary of my capstone research about stormwater management at San Francisco Bay Area transit agencies. I looked at how transit agencies can improve and organize their stormwater plans to extract the greatest resources from stormwater at the least cost. Urban stormwater runoff is a leading source of pollution in U.S. waterways. Urban areas have high levels of impermeable ground cover, like pavement, that prevent precipitation from infiltrating the ground where it falls. Instead, stormwater becomes runoff as it flows across paved surfaces, picking up PCBs, mercury, heavy metals, and bacteria, and carrying them through pipe systems that treat stormwater exclusively as a flood hazard. These systems are called gray infrastructure, and they don't consider impacts to downstream receiving waters. Gray stormwater management disrupts the hydrological cycle by increasing peak flows and total runoff volumes. Negative consequences of disrupted water cycles include reduced groundwater, increased erosion of streams, and lost wildlife habitat. The landmark Clean Water Act of 1972 regulated wastewater point discharges for industrial and construction sites, but only in 1987 were non-point sources of pollution like urban stormwater regulated. The National Pollutant Discharge and Elimination System issued 2 permits for municipal separate storm sewers, also called MS4s, in the 1990s. Transit agencies follow the Phase II permit for non-traditional MS4s. Their permit doesn't have numeric limits on pollutant concentrations, but instead uses narrative and descriptive criteria that gives agencies a lot of leeway to design their programs. The permit requires that MS4 address public education and participation, illicit discharges, runoff from construction and post-construction development, and good housekeeping. MS4s can combine various best benefits to meet the above objectives. There are structural BMPs like bioretention rain gardens, and that treat contaminants through biological and chemical processes, as well as non-structural programs like recycling incentives that can keep toxic materials out of runoff to begin with. Transit agencies struggle to implement effective stormwater programs due to a lack of dedicated funding. The flexible narrative permit language also enables MS4s to minimize or otherwise let stormwater management take the back burner. To maintain the beneficial uses of local waters, our research indicated that transit agencies should create green infrastructure plans that organize their goals, document their progress, and identify resources. The plan should include agency-specific goals for BMP implementation that have defined schedules as well as desired outcomes. Goals will be tailored to site and community considerations, whether those be elimination of particular pollutants of concern, preservation of habitat, or the creation of recreational space. Technical guidance for BMP selection and design are also included in GI plans. The final piece of the plan is the identification of resources. This includes local grants and loans that may be available, as well as partnering opportunities within the watershed. GI plans provide structure and justification for stormwater improvements that will help these agencies meet the demands of growing urban populations and climate change in the years to come. Now I'm happy to take any questions.